Okay, so got example 8 here, and hopefully example 8 is something that you have already done. If you have not done this, please pause the video, go work example 8, making sure you're getting in that practice. Really, really important that you are attempting these examples before you look at the answer because it's not helping you if you're just looking at me do the work. So if you haven't done it, pause and go work on it. Okay. You have worked this problem, you're ready to see how awesome you did. So hopefully you understood that you're looking for this right here, which is the empirical formula, meaning that all of those x's are going to be replaced by numbers, and that it's the empirical, which is going to be the lowest ratio that you can get, meaning you have simplified it, divided it down, etc. So let's go ahead and go through this first step right here, convert to moles. So the thing that I think sometimes students struggle with these empirical formulas is they don't know where to start. Well, if you can just remember that, hey, I've got to convert to moles so everything can play nice together, then you're going to probably be okay. So first step, we're going to convert everything into moles. All right, so I've kind of started this here. I've got my nitrogen, and then there's my mass value from my periodic table. And so where we go, we got all of our atomic mass values or gram formula masses. And I just got those off the periodic table. So there's nitrogen right there. There's your carbon, oxygen. You guys get the handle of that. You should be fine with that kind of stuff. So let's go back here and clean this up a bit. And want to point out one thing. Sometimes students ask, okay, Mr. Reese, why is this not diatomic here with this nitrogen? Nitrogen's diatomic. What about this hydrogen? What about this oxygen? Okay, great question. Diatomic is only used when they're by themselves. So I would say, okay, if you want to figure out if something's diatomic, come over here and look at our formula. Are these by themselves? The answer is no. If they're not by themselves, then we don't care about diatomics. Okay, so it's only when they would be alone and by itself would it be diatomic. So, all right, so we're going to run this through. We're going to come up with 4 numbers. Now you're going to notice that conveniently my units are canceling, which is great. See, grams are top and bottom, top and bottom. You want to have your conversion factors look like this. Good chemistry student does not take shortcuts, okay? So let's go run this through on your calculator. You've probably already done this, so I'll just do this real quick. And so I'm going to take my 1.12 divided by 14.01. And then with the 4 sig figs, I'm going to end up with 0. Oops, don't want the highlighter. Going to go with the 0.07994, and then that's going to be moles. The second one, 0.161, and I'm going to divide that by 1.01, but this doesn't get as many sig figs, so it's going to be 0.159. And we went over the sig figs in the previous lesson in the 1.1. So you need to at least be trying the sig figs. Don't be writing down your whole display. This one, with the 3 sig figs, it ends up rounding quite nicely to 0.400. So it's 0.0. Sorry, I miswrote that. It should be 0.0400. That is very important, so I don't want to mess that up. And so on my calculator, it's 0.0399666694. We don't want all that. We want you to use sig figs so we can get a value that is a bit better. So 0.64 divided by the 16 is going to give us the same thing. Okay. Step 2. Pretty important to know the steps. So step 2 is going to be divide by the smallest. So we're going to divide by the small Gonna run out of space. We'll say small value. Okay, so divide by the small value. Clean up that U, doesn't look very good. Kind of looks like my V actually. So divide by the smallest. And I really encourage you to take good notes, to do things like this in the margins, giving yourself the best opportunity to have things to go back and look at and say, okay, I understand what's going on here because I wrote some notes to myself. So we're going to divide by the smallest. So which one is the smallest? Well, right here, these values are tied for the smallest. Now, I made a mistake earlier and I wrote down 0.4. Well, that would have been a big problem because I would have not been dividing by the smallest value. So when I say divide by the smallest value, I mean you divide all of them. So this gets divided by 0.04. So does this. And you guys kind of get the idea. They're all going to get the same thing because whatever you do to one, you have to do to all of them. Now, this is going to turn out pretty nice and clean. And usually they do. They either give you nice clean decimals like 1.5, 2.5, 2.3, whatever, or they're going to give you nice whole numbers. So let's do the math on this. So this first one, you're going to go 0.07994 divided by 0.04, and you're going to get 1.9985. Okay, I'm going to write it here. 1.99, and with sig figs you only get 4, and so then that 8 actually goes to a 9, so it's going to be 1.999. All right, that number is close enough to round, so we could round that to 2. That would be fine. Okay, it's within a tenth. If it's within a tenth, you can round it. So next one's 0.159 divided by 0.0400. And that one, and I'm going to have to, my space is kind of tight here, so I'm going to squeeze that one right in here. 3.975 is going to become 3.98. Okay, well, 3.98, what can we round that for? What can we round that to? We can round that to 4. It's within a tenth, 3.98. Okay, the next one, I don't think I need a calculator to mess with that. That's going to be a 1, and then this is going to be a 1. Okay, so we have created 3 nice whole numbers, a 2, a 4, a 1, and a 1. Now, let's say they weren't whole numbers. Let's say that they were like 1.5s, 2.5s, 4.75, 4.25. If they're not nice whole numbers, you'll need this step 3, which is to multiply everything by a value that gets them to whole numbers. So you're going to multiply halves by 2, 0.3s and 0.6s by 3, and 0.25s and 0.75s by 4. This step was not needed here because we already have our whole numbers. But that step was needed on the previous example. So what do we do with these? These are going to become our coefficient, our coefficients, our subscripts. They're going to become our subscripts. So 2 is going to go right there. 4 is going to go right there. 1 is going to go right there. And 1 is going to go right there. They become the subscripts, the small numbers. And so the 2, I know it goes here because the 2 is from nitrogen. So so that's the connection is, okay, that's nitrogen, so we're going to use the 2 because that's how we got through. That's the value that we got when we went through the process. So let's go ahead and slide this up and write down our final answer, which is going to be a formula. So that's going to be N2H4C1O1. So NH4CO. And so that's the formula. Now, this can be written different ways, but these are the pieces that you need to get the correct answer. And there you go. Hopefully you got that, and hopefully you could, run through this and get the answer on your own. Now, if you didn't, hopefully you're spotting the mistake. The mistake is usually right here. If there is a mistake, the mistake is usually this step right here. Students forget to divide by the smallest. They just want to round right after they do the initial math. So that's going to be taking care of that example. And I'm going to pause the video here, and then we're going to start